our team consisting of 2 software engineers and 2 hardware engineers. And the main idea of our product is to create a smart, invisible aligner case that will allow to deal with patient compliance issues. It will perform such operations as tracking the time of usage, checking whether the proper aligner is being used, and potentially detecting such metrics as pH and the amount of moisture in the mouse, which will help prevent several diseases. It will basically be a combination of hardware and software, where the hardware components would be communicating the data to a software platform where we'll perform analysis. And so far we participated in a rotary catheter and created a basic prototype, and in the spring semester we will implement some more interesting features, and my team will talk about that.
So how do we communicate? The team communicates using a Facebook group as well as a team drive to organize our data. We are in contact with our advisor, Dr. Khanna, for bi-weekly meetings, and we email her as needed when questions arise. Our goal by demo day is to have a functioning case that can take in information on the aligner's presence as well as transmit it to a PLE using an external interface where it will be easily viewable.
So in order to accomplish this, on the software side, we'll be creating a node-based server. A node-based server will both sort of track our data, probably a SQL database, and also serve our web app, which will be used by temp providers to view the data. Then on the client side, we'll be using Swift for an iOS app to sort of receive the data via Bluetooth from the case.
So the hardware is straightforward, though it will have to be custom made because currently invisible aligner cases are just a piece of plastic. So in SolidWorks, we'll be developing a model that has space for all of the technology and is safe to use as a result. The technology on the case involves a simple pressure sensor, a scanner, because we will be in touch with manufacturers to develop some sort of RFID for the aligners that will be placed in the case, and then a microcontroller such as Arduino with a Bluetooth-enabled component attached, such as a Adafruit trinket, in order to enable the Bluetooth capabilities. That's for this semester at least. Next semester we will be adding.
So we split up this semester into a bunch of mini milestones. Our first milestone by next week is to have a really basic rudimentary system set up where we have like a mobile app that can access the Bluetooth interface, and we have a case that has a Bluetooth component, but they don't necessarily talk to each other yet. The strategy is just to have like parts there. Not very useful, but great first step. Then the following week, the plan is to have them start talking to each other, and they're not really like they're want to be speaking like. They're going to be speaking different languages, like Chinese and French, but they'll be talking, they'll be like sending bits to each other, they just won't be speaking the same language. Then the following week, we're going to synchronize those schemas and have the web app working, and then by the following week, we'll have this whole system set up. We can then hopefully actually test on a real patient.
From the hardware side, the way those components will work together is that right now we actually already do have, a very simple kind of proof of concept. And now what we're going to do is instead of using, the existing aligner case that we just kind of stuck a sensor onto and like hooked up with the microcontroller, we will be customizing one. And like I said, in SolidWorks within the next, let's see, 11, so next weekend we'll have just the case printed is the goal, and now fully outfitted will be another week after that with, the 4 hardware components that we'll need, 5 I guess for the battery. And yeah, by the end. But within a few weeks, we hope to have, the beginnings of them talking to each other with the functionality I mentioned at least somewhat developed. And now, once we have that, we'll go into what we want to have for the spring.
And as for the budget, we've already ordered the parts worth around $250, but it was way over the amount that we actually need to be using, because the microcontroller is about $12. We're trying to minimize the size of it because we only need limited functionality from that microcontroller. We also need a pressure sensor,
which we have in Deadkin.
Which we have in Deadkin, Wi-Fi module that is worth about like $12. So the overall rough estimate of the price should be around $50 at first, and then we obviously need to incorporate the price of the further research that we'll have to do into the other components that Sarah was talking about right now.
Yes, so one of the exciting things about this case is that there is a really strong ability to add functionality. And as we've met with different people in the dental school, our advisor, and just spoken to people around campus, we've learned about some of the ways where we can expand this case and solve more problems. So one of the problems that was brought to us was moisture detection. So many people have dry mouth diseases, but do not actually recognize it. So we are looking into the possibility of using this case system for moisture detection. A second application of this case is with pH evaluation. Dental caries, or as we probably know them as cavities, can be detected and prevented if you know what the pH in the mouth is. You can see if someone might have a cavity or actually already has a cavity. And then the third feature that we are looking into adding is GPS capability. So enabling the user to track the case, as well as having an additional usage metric to try to understand user behavior. So where are you not using your aligner? Where are you using your aligner? And then finally, this is Alex's favorite part, but the social aspect. So something that people have found with patient compliance is that it ultimately is more effective if you add in a social aspect. So people have seen that with different medical versions, but also with Fitbit, we have seen that users are more engaged when there's an aspect of social pressure. So the idea would be to create a network of users and track your progress to a smile.
Thank you.
Wait, and then